Hello everyone. So this is the very first video in this series I called Musing Mondays, where I'll pick some mathematical theorem or conjecture and try to explain it to a much wider audience. Now this very first video has to do with a way in which we can prove that square root of 2 is not a rational number using Fermat's last theorem. Now what makes this proof really interesting to me personally is that we learn very early on in our schools that the square root of 2 is not a rational number using proof by contradiction. And also, as some of you may know, Fermat's last theorem is this holy grail of a math problem which was unsolved for more than 300 years until it was completely settled by a guy named Andrew Wiles in 1996 using some of the cutting edge mathematics of that time. So let's try to see how this proof works.
Okay, so let's try to understand how this proof works. But before that, take this identity and firstly we'll verify whether this really holds. So we'll expand both of these expressions out using formula for cubes, and we'll see if after doing all the manipulations and calculation whether we get 42 cube. So let's expand both of these expressions, and notice how both of these expressions are almost similar except for the minus sign over here and there. So after adding, these terms cancel out and we are left with this, which eventually evaluates to indeed 42 cube. So it's verified. Okay, so let's come back to this identity again for a sec, and notice how this whole expression looks awful lot like Fermat's last theorem equation for exponent 3, except that there are no variables this time, but those variables have actually taken certain values. Now, in order to prove that square root of 2 is not rational, the argument goes something like this. Let's say square root of 2 were a rational number, then both of these expressions would evaluate to some rational numbers a and b, and then we have another rational number c. So overall we would get rational numbers a, b, c such that a cube plus b cube equals c cube. But that can't possibly be true because Fermat's last theorem, which is now an established theorem, says that there are no such ABC such that a cube plus b cube equals to c cube. So this is how you prove that square root of 2 is not a rational number using Fermat's last theorem. Well, not so fast. What Fermat's last theorem actually says is that there are no non-trivial integer solutions to Fermat equation. So for the sake of being slightly more rigorous and to make sure that our proof really involves Fermat's last theorem, we have to establish these two facts. So firstly we have to make sure that square root of 2 is neither plus 18 by 17 or minus 18 by 17, because if we substitute it back over here, one of these terms goes to 0, which gives us what is called a trivial solutions to Fermat equation. Next we have to establish that if square root of 2 is a rational number different from these two, then it gives us three integers a, b, c, which are counterexample to Fermat's equation. So these two are not hard to establish.
Now, both the claims in exercises 1 and 2 are really easy to prove, so I highly encourage you all to prove them yourself, and once you have done that, you have got a complete proof of square root of 2's irrationality using Fermat's last theorem. Now, there's one more point that I would like to add about this whole proof, which I find really interesting, and it is that it has been established back in 2004 that this is the only way to prove square root of 2 is irrational using Fermat's last theorem, and the way it has been established involves methods which are not so different from Andrew Wiles' original method to prove Fermat's last theorem. So now, for those of you who understand a bit of abstract algebra, what the author showed in that 2004 paper was that if you consider analog of Fermat's last theorem for a ring of quadratic integers of the form a plus b square root of 2, where a and b are integers, then this analog of Fermat's last theorem does not hold in exponent 3, but it does hold in other higher exponents like 4, 5, and etc. And what he further showed was that all the counterexamples in exponent 3 are generated from one single counterexample, and that generator gives us the identity that we used previously to establish square root of 2's irrationality. So comment down below if you want to look at that paper. I can DM you all.